My name is Aidan, and this is my demonstration of the conservation of angular momentum and how it relates to the Hubble telescope. So who here has heard of the Hubble telescope? Well, for those of you who don't know, the Hubble telescope is the most advanced telescope known to mankind, and it's in space above us. It's been in space for around 26 years, and it orbits the Earth every 96 minutes. That's pretty fast, right? Well, it's so fast that if you were to ride the Hubble telescope, it would only take you 10 minutes to go from one side of the US to the next. So, for those of you who don't know, the Hubble telescope takes pictures of deep space with nearly 100% clarity. That must be pretty hard though, right? Since it's going so fast, how does it stay stable and get those 100% clear pictures? I mean, if me or you were to run around with our phone and just whip it around and try to take some pictures, the pictures would obviously come out less clear, wouldn't they? Well, I'll show you how in a moment, but please first observe these two eggs. One of these eggs is hard-boiled, the other is raw. And it's going to be your job to try to guess which one is which, okay? Please pay attention to what they do before and after. I'll do it one more time for you guys in case you missed it. Ready? Well, if you guessed this egg, then you'd be correct. You can tell because after I spin the egg and after I stop the egg, it keeps spinning. And this is because I've only just stopped the egg. I haven't actually stopped the liquid inside, so that keeps it moving on its axis. Now this perfectly demonstrates the principle of the conservation of angular momentum. And the principle of conservation of angular momentum comes into the scale with the gyroscopes. The gyroscope works the exact same way as the eggs, except it's just used in the Hubble telescope. Now I'm going to spin the gyroscope for you to see just how it measures the conservation of angular momentum and just how it works. So here I'm going to put it on its axis. See how it's spinning, and see how if I move it, it starts to spin faster and faster in turn. Well, that was it correcting its axis. You might ask, why does the Hubble telescope need this gyroscope? Well, this gyroscope helps the Hubble telescope locate new targets and lock onto them. It also helps it move horizontally, as in space you can't really move horizontally. You can move vertically with your body, or in this case the Hubble telescope, but it cannot move horizontally very easily. So it uses the gyroscope to help identify where to move and how to move. The Hubble telescope also uses the gyroscope to help stabilize itself, as when the gyroscope starts to move side to side, the Hubble telescope will know that, oh, it's not on balance properly, and will move to make sure the gyroscope is spinning perfectly still. Can you think of any other things in real life that might use a gyroscope? I'll give you a hint. The gyroscope is used to navigate, so it might be used as some sort of type of vehicle. Well, I'll give you some more hints. You use this thing to fly, you might use it on vacation, you might take it over an ocean. If you guessed a plane, you're correct. A plane uses a gyroscope to adjust its angles and make sure it's staying on course. So if the plane is going down, the gyroscope might spin a different way, and the pilot will know to correct it. Thank you for listening to my demonstration of the conservation of angular momentum and how it helps the Hubble telescope.